Hi, my name is John. Good morning, or afternoon, or evening. Probably studying the evening right now. Anyways, we're going to go over Chapter 7 of Charles P. McKeague. It's called the ambiguous case. Most books call it the ambiguous case of triangles. So I'm going to put of triangles, okay, for shorthand notation, and we're going to be going over the ambiguous case. Some of you don't understand what the word ambiguous means. It's okay. Some of my students they go, what does ambiguous mean? It means unclear. And we'll go over the reason why it's going to be unclear. Sometimes you're going to have 0 triangles. You're going to have 1 triangle. You're going to have 2 triangles. You're not going to have more than 2, so you're kind of lucked out. But sometimes there's 0, 1, and 2. And the reason and the way you can have 0 triangles is very simple. You can use the law of sines for short. If you see that, yes. You can use the law of sines to try to see if it doesn't work out, then there's going to be no triangles. Sometimes there's going to be 1 triangle, and sometimes there's going to be 2 triangles. We're going to be going over this and the second part, the 2 triangles, very carefully. Before we do that, though, this chapter contains a lot of formulas involved. So I'm going to teach you guys some mnemonic devices on how to organize your formulas. So I made a notebook. I have a notebook, excuse me. This notebook's really nice. It's one of those hard tops where it's made out of plastic, so that it's not one of those cheap 70-cent ones. It's about $1. I got it from QVC, I believe. And this is the one. Some of these I give this to my students. Anyways, I'm running out. This is my last one. What happened is on the front page right over here, I wrote down LOS. And in the back, I wrote down the formula. Sine of A over A equals sine of B over B equals the ratio of sine of C over C. And then, what is the quick check? We discussed this last time in 7.1. The quick check is opposite, largest angle, largest side. And of course, opposite smallest angle is the smallest side too as well. What is the arc length formula? We discussed that too a little bit. I don't know if you guys remember it. It's arc length S equals arc theta. Arc length S is equal to arc theta, theta being in radians. So you might want to put, there's a caveat. The caveat is that it's going to be in radians. When do we use the law of sines? So we're going to use it for AAS situation, angle side angle. And now we're going to hit the ASS situation. I can't say that word. Some teachers call it the donkey. We're going to go over the AAS situation a little bit. So you can actually write down information in here like this for whether you're taking notes for that you need to memorize for U.S. history, which is AP or college prep. You can do it for your vocabulary list. You can do it for Spanish or French vocabulary words that you need to memorize for government too as well. It's a very good way to organize it. It's better than those note cards that you have, flashcards, because they're bulky, you lose them, and this one's all fits in real nice binding. So you get maybe two or three of these, one for U.S. history. Sometimes students put in the middle, starting for U.S. history, or whatever you guys want to do. Okay, so this is some really good paper to have as a tool to memorize things. So let's get started. The ambiguous case. I'm going to give you an example of what happens. Let's say for instance the angle A is equal to 30 degrees. It's a real nice small angle, and little a is equal to, let's say, 2, and B is equal to 10. So let's try to draw this out as accurately as possible. So I have a ruler right over here. And this, you can draw this as long as you want. And that's about a 30-degree angle right there. Pretty close to 30 degrees. And let's say this length is 10. So that angle is 30 degrees. It's fixed. Because they tell you the angle 30 is fixed. You can't move that angle. And this length is fixed too as well. This is B. I'm going to label this A, excuse me. B is 10. Now when we look at length A, which is opposite here, it should look like this. But if this is 10, this is only 2. 2, 4, 6, 8. It should be a little bit smaller than that. But still, what happens is, since this length is 2, you can kind of arc it back and forth. They'll never touch the side. And therefore, you're going to have no triangles. This is the way you see it graphically. Let's do it mathematically. Let's suppose it does make a triangle like this. A, and little a is 2, and B is 10. And we're going to try to find out what big B is. Sine of A over 2 is equal to sine of big B over 10. And using the law of sines right here, we'll use black. Black seems to work a little bit better. Sine of 30 is 1/2 divided by 2 is equal to sine of B over 10 multiplied by 10 to both sides, multiply, cross multiply, you get 5. 10 times 1/2 is 5 is equal to 2 sine of B divided by 2. The sine of B is equal to 5/2 or 2.5. When the sine of that angle is greater than 1, you can never ever have an angle. And we'll try to work it out on a computer right over here. We're going to take the sine, excuse me, how do you find the angle? You take the sine inverse of 2.5. There it is right there. And you can see that it comes out domain error. Okay? So you can tell using the law of sines now that you won't have zero triangles. Therefore, that's a symbol. Therefore, zero triangles. Okay? So we covered the case with the zero triangles. Notice it doesn't quite hit the bottom of this side. Notice that this is fixed. This is fixed. You can't go farther or smaller. And this length is fixed. It doesn't tell you that this angle is fixed. That's called a hinge effect. It's like a hinge on your door. You can move the door back and forth, but it will never touch the door, the edge of your wall, basically. So there it is. We basically covered example 1. Okay. Example 1, they used 10, 6, the length of 6 instead of 10. The angle was fixed at 30. They used 2 right here, and so you got a problem. Now let's use the donkey. Okay. I'm not going to call it ASS. I'm going to call it the SSA. Okay. Same thing. ASS, SSA. Just sounds a little bit better. So let's see what happens now. The reason why in geometry the 5 different ways to prove congruent triangle is the SSS. SAS, the opposite is ASA, AAS, not ASS, and the HL. Now we can prove that the SSA actually has some ambiguous cases. I'm going to try to draw one for you. That's a little bit off, but it's okay. Suppose this is 50 degrees. And this length is 10, or 10. And let's suppose this is 9. This one's fixed, that one's fixed, and that length is fixed. The first triangle you're going to end up, I'm going to use a different color here. You're going to end up with a triangle, the biggest one, the outside one. That's your first triangle. And the second triangle that you're going to end up with is the smaller one right here. This is fixed, this is fixed. Little a is also fixed, it's at 9. So you end up with 2 different triangles, the green one and the large one, which is the orange one. And that's the reason why the donkey was not used in geometry, whether it's honors or college prep. It really doesn't matter. You couldn't use this word. So, but now in trigonometry, you'll actually have to figure out the unclear case, the ambiguous case, okay, or cases. So let's look at example number 2 and see if you can try to work it out. Okay. Example number 2 says find the missing parts of the triangle. I'm going to use black. And this is on the side right there. Little a is equal to 54 centimeters. Little b is equal to 62 centimeters. And big A is equal to 40 degrees. Notice also that A must always be less than 90 degrees. If A is greater than 90 degrees, I'm going to write this down. If A is greater than 90 degrees, then 0 triangles or 1 triangle, but never 2 triangles. Never 2 triangles. Okay? So we got the case that the angle A is less than 90 degrees, and we'll probably end up with either 1 or 2 triangles, or 0. 0, 1, or 2. Let's try to figure out the missing parts. We're going to draw it out first. That's about a 40-degree angle. And here it is. We always label this side A. Opposite that, it will be little a, which is equal to 54 centimeters. And little b is going to be 62 centimeters. So we're going to use, and here's big B, of course. Label that little b. We're going to use the law of sines to see what happens. Sine of A over 62 is equal to sine of B over 54. We're going to cross multiply. We're going to give that angle 2 to give you the angle, which is 40 degrees. So I'm going to replace this part with 40 right here. I'm going to cross multiply. 54 times the sine of 40 degrees is equal to 62 times the sine of the angle B. And to get rid of that 62, what we're going to do is we're going to divide by 62, that gets rid of that. And how do we solve for this angle B? Well, to get rid of the sine, you can't divide it by the sine. Half of you would try to do that. Not half of you, maybe a quarter. You can't divide it by sine, you have to take the sine inverse. And let's actually work this out. So you take the sine inverse of 54 times the sine of 40, in parentheses, divided by 62, and you'll have to put in parentheses on that one. It comes out to be approximately 34 degrees. So let's use that. B is equal to 34 degrees. And there it is right there. Oh, excuse me, big at 48. Let's see what happens here. 62, did I input it wrong? They get 48. Let's see, sine of 40 over oh, wow, wrong one. Oops. So let's try this again. This should have been 54, and this should have been 62. So it should have been 64 here, and then 54 here. 62 and 54.